So, so I know from the start of the day, we were going through this different types of how we kind of leverage Kubernetes. We had sessions where people was trying to relate Kubernetes with an analogy of a restaurant. And then we also learned the security aspects of it. And then we had ePPO sessions, then KDA, whatnot. It's kept getting more and more interesting. So I'm pretty sure most of us will still be worrying about how do we manage Kubernetes when it comes to air gap environment. So not to worry anymore. So we have a next speaker who's going to talk about the air gap environment. So I would like to invite Siddhant. So he is the product executive of Devtron. So he'll be discussing the concept of running air gap Kubernetes cluster. Siddhant, I'm handing over the stage to you. It's all yours.
Okay, finally after that we have it. So hey everyone, is everyone awake? Awesome. So the talks about air gap deployments. So I'm just going to try to help you understand whether air gapping your cluster is for you or not. A sneak peek of what's to come. Air gapping is actually quite difficult, and even after you have created an air gap cluster, managing it is a headache. So I'm going to talk about why exactly it's a headache, what all things will go in air gap, and which all industries are actually using air gap right now. So, hey everyone, I'm Siddhant. I'm a product executive at Devtron. I'm also one of the organizers for the local CNCG group at Nasik. We mostly do online webinars. And I'm also a tech and fitness nerd, and I love to create content. I write a lot of blogs in my professional career, and I love recording videos and publishing it on my YouTube channel. So if you want to connect with me, there's my bio.link. You can connect with me and feel free to DM me on Twitter or LinkedIn. So the very first question, what is air gapping? Anyone here who's aware about air gapping from the non-technical perspective? Okay, so talking a little bit about physics, everyone's used water systems, right? Faucets and everything. Those have a concept called as air gapping. Whenever you start the faucet, you get a stream of water, right? And when you close it, none of the water is flowing back. That's because there's something called as an air gap within that faucet. That air gap prevents all of that water from flowing back. So contaminated water is not going to get mixed with fresh water. That's the basic crux of what air gapping is, introducing a layer of isolation between two entities. So when we talk about it in terms of tech, in terms of machines, it's simply disconnecting your machine from the network. That can be done in multiple ways. I'll talk about that in just a few minutes. But yeah, the crux of air gapping is your cluster or your system is completely disconnected from the network. So normally, this is what your Kubernetes cluster would look like. The center thing is your cluster, and it's connected to all these different sources. You've got your Git registries, probably picking up code through your CI/CD pipelines, throwing it into the clusters. Then you've got your container registries, OCI registries. You've got your Helm charts. So all of these different sources, they're not on the same network as your cluster, right? They're all living in different places, maybe on AWS server, on Azure server, wherever. So you're pulling files, you're pulling data from all these different servers and putting it all in your cluster. That's how a cluster is working normally. Now, in the case of air gap, all of these connections are gone. You've got the cluster and just the cluster, nothing else. So now when you want to put some files on it, you want to put your actual application on the cluster, or you want to upgrade the components of the cluster. How exactly are you going to get the files in? You're gonna have to bring in physical media, USB drives, floppy disks, CDs. Might be a little old to say these, but two of these things are extinct. I don't think anybody uses CDs or floppies these days. It's just pen drives as physical media. So basically, yeah, an air gap cluster is completely cut off from the network. So you're gonna have to bring in physical devices to get files on your cluster. And if you have to access it even, you're gonna have to go and physically access the server. You don't have any sort of remote access or SSH. completely disconnected from the network. So how exactly are you going to go and SSH there, right? So you'll need physical access to the server. What I've just told you is what we call as a true air gap. So this is a 100% air gap cluster, absolutely zero network in this one. But in actual use cases, it's slightly different. In actual use cases, we do something called as pseudo air gapping. So your cluster or your systems are air gapped to a certain extent, but not fully. Network traffic can still go in there, but not directly. There's a, there's a method to it. I don't think I have a slide for that. So I'll just try and mention it. Let's say you have your cluster over here. Its network is almost isolated except for one single port. This port will not directly go and talk to something like a chart store, a Helm chart repository. It will instead communicate with a proxy, and the proxy is where all the traffic will come through first. Only through the proxy, the traffic can access the actual system, the air gap system. That's what we call as a pseudo air gap. So yeah, there are two types of air gaps. You've got a truly air gapped one, where there is literally zero connectivity. And if you want to access the cluster or the system for that, you'll have to physically visit the infrastructure. And then there's the pseudo air gap, where you can communicate through the cluster, but it'll be through a proxy. So I think by now, everyone is aware that how much of a pain it is to manage an air gap cluster, right? Without a network, and especially if you're using Kubernetes, something that relies heavily on the network itself. So now let's talk about why exactly or in which industries would you want to consider using air gap clusters. So first you've got fintech companies. You've got companies like BharatPay, Razorpay, the NSE stock exchanges. I'm pretty sure that everyone is aware of these names. Now in these systems, if it's not air gapped, literally anybody can access the main system, right? Well, not anybody, but if you have a hacker or any sort of malicious parties, you want to make sure that it is very difficult for them to get into the system and try and manipulate it. Imagine somebody hacks the stock market. All the stocks might go up, down, crash, whatever. So in that case, these systems need to be air gapped. And similarly, they use the proxy model, which I just talked about. They have the cluster, it's talking through an external proxy, and that's how these fintech organizations handle their clusters in an air-gapped environment. Next, you've got banks. So even in banks, if your bank account is suddenly drained, then you're going to be in a panic. And even the banks are going to be in a panic because you've lost all your money. So yeah. So all of these different banks, even they use an air-gapped server. Next, we've got healthcare. Healthcare industry requires air gapping. They need a really high level of security as well, because you don't want any of your patient data leaking, right? And patients are not just people like you and me. Hospital patients can even be government officials. It could be someone from the army. You don't want all of their medical data leaking out. So in that cases, you want to make sure that data is as secure as possible. Hence, you'd go ahead and use air gap. Then again, in the military as well. So if military communications leak out, do I need to say anything else? Military communications leak out, then there's quite a big risk. Then you've even got nuclear missiles and stuff. Even that is somehow controlled via radio waves, correct? You don't want that to get into the wrong hands. So in that case, you're gonna have to have some sort of an air-gapped system. Even all the radio frequencies which are used by the military, those are on an air-gapped network. Then the governments as well. By now you already know that air-gapping systems is making them secure. You're using it for extra hardening. So this is somewhere where you would really want air-gap system, especially for whatever sensitive data you've got. And then you've got the aerospace industry as well. So basically, any industry that requires a really high level of security, over there you would want air gapping. But air gapping is just part of the picture. On top of having an air gapped environment, you would also have all of your other security practices. For example, you might be setting some policies. You might be using scanning tools like Trivi or Claire for Kubernetes environments. Air gapping is an additional step on top of all of those. It's not that you air gap your environment and then you're done. You don't need to worry about security at all. That's not the case. You will still have to use all those traditional security practices on top of your air gapped environments. Now, there's this one really good example which I came across, which is in the aerospace industry. Everyone's traveled by flight? Yes? So in international flights, you get in-flight Wi-Fi. You have to pay for it, but you have that option. So there's a very interesting architecture for that. Whatever in-flight entertainment you use, the in-flight Wi-Fi that's used by the customer, the flyer, that lives on its own separate network. And whatever network the flight operator is using for communicating with the ATC, air traffic control, or whoever they need to talk to for the routes and everything, that exists on a separate network. Now, the external network, imagine this one big box. That's your actual ATC network, where the flight operator is going and communicating to wherever they need to make sure that the flight is safe. And inside that, you've got a second network. The second network is what you're able to use for getting Wi-Fi access, internet access while you're in the plane, thousands of feet above the ground. That inner network, that directly goes and communicates with a satellite. So there's a layer of air gapping between the ATC network and the actual customer Wi-Fi network, right? The very first example which I gave you about air gapping, about the water faucet, what was happening over there? There was literally an air gap created between the contaminated water, the water that is already flown out, and the water which is already in the tap, right? So that was a layer of air gapping. Similar thing happens here in the aerospace industry between your actual radio networks and the in-flight entertainment Wi-Fi network. Now, about how you can go ahead and do air gapping. So these are a couple of tools which are quite useful for creating air gap networks. And I'm going to discuss a little bit about these tools and then look at how you can use all of these tools together. So first we have K3s. K3s is just one of the distributions of Kubernetes. It helps you create a very lightweight cluster. The main thing about K3s is it discards a lot of the things which Kubernetes has. Not the core components. You still have the essential components, but whatever is additional, whatever is not needed for running a cluster, K3s just discards that. If I remember correctly, I was looking at K3s recently, and if I remember correctly, the requirements for just running a cluster is 1 core of CPU and 512 MB of RAM. So it's quite lightweight. The lighter weight you have, the lesser your attack surface is. Even though you may have air gapped your network, keeping the attack surface really small is always going to have its benefits. Then there's RKE2 as well. It's a cluster that was specifically designed for government and military use cases. So it has a lot of the security compliances which you would want. Even if you check out its documentation, it's designed in a way that keeps security at the forefront. Then you've got Minayo as well. Minayo, you can use it as a caching solution. Once you have introduced some data in your air-gapped environment, I'm pretty sure that chances are you're going to reuse that data again and again. For example, you might have put an image in there, a container image. You might want to create the deployment for that image multiple times, right? So in that case, you can cache it within Minayo and just keep reusing it inside the environment. Then there's Harbor. Harbor is a self-hosted container registry. So you can host that within the air-gapped environment, and that can have your Docker files. It can have your container images, your Helm charts, and whatever is OCI compatible. Then there's Zarf as well. Zarf is like a package manager from what I have seen. So let's say that, let's take these two speakers as an example. Let's say the speaker that's further away is the air-gapped environment, and this one right here, this has complete internet access. So on this, I can install Zarf. I can use a Zarf install command to get all of my packages, download whatever Docker images I require, my Helm charts, whatever, and combine it into a Zarf binary file. Now this Zarf binary file, I can copy it onto my physical media and put it in my air-gapped environment. Install Zarf on my air-gapped environment, run a simple Zarf install, give it the path to the Zarf binary, and I have all my packages installed on the cluster. So that's what Zarf is. It's actually quite an interesting project. So if you're running air-gapped environments, do check it out. It's totally an open source project. And then there's the Devtron as well. So Devtron is a Kubernetes management solution. We have a Kubernetes dashboard, which you can use for managing the entire cluster. You can point it to, let's say you've deployed Harbor for managing your OCI registries. So you can point to Devtron to look at your particular Harbor instance, wherever you've set it within the air-gapped environment. And from there, you can keep pulling your container images, your Helm charts, deploy and manage your applications. So we actually at Devtron, not recently, this happened quite a few months ago. We have a couple of clients who are actually using air-gapped environments. And within their architectures, we have it something like this. So this little box over here is the actual air-gapped environment. Inside that, you've got a cluster running. And on top of that cluster, we've installed Devtron as a solution for managing the entire cluster and application lifecycle. So the story starts outside the air-gapped environment, obviously. You've got your code on GitHub. You would want to build it first. So we've got an external Devtron instance, which will pull all of the code. It will build the container images, run whatever security scans and stuff you need. And it will push the image to a container registry, or rather an OCI registry. From that OCI registry, that particular image or that particular Helm chart is pulled by this Devtron instance, which exists within the air-gapped environment. Now it's communicating to the external through a proxy. So it's not directly communicating. It's an example of a pseudo air-gap, right? There is something else which you can do as well. This isn't in the slides. This is just for your imagination. You could theoretically push your container image to your container registry. Run whatever security scans you want. As far as I'm aware, ECR, ACR, Google's container registry, when you push images over there, it has its own built-in security mechanism, which will run some scans and everything. So you can have those scans running. And then within your air-gapped environment, you could have an instance of Harbor. Harbor can mirror all of the data which exists on the container registry. And then your actual air-gapped instance, that can take the images directly from Harbor. So that would be a case of true air-gapped environment. You could also alternatively grab the container registries on your local system, package them on some sort of physical media, and plug it into the air-gapped environment. Now, obviously, there is a risk that whatever you're plugging into the air-gapped environment, that's going to have some sort of security threats. So for that case, you need to ensure that whatever you're putting on your physical device, it is secure. And that's where all your scanning tools will come into place. Has anybody heard about the Stuxnet virus? Okay, so around 2012, there was this one virus called as Stuxnet. I might be really butchering the pronunciation, and I'm sorry about that. But what this virus basically was is it was injected into some military system, if I'm not wrong. And because of that, the hackers were able to get complete access of that. So this was a really big security flaw. And this did happen in an air-gapped environment. While it is quite difficult to hack into an air-gapped environment, it's not totally impossible, right? People have done certain POCs in which they have used radio frequencies or light frequencies, literally. They have somehow managed to use light frequencies to inject malicious code into that air-gapped environment. And that's how they had access to some really sensitive information. So yeah, this is much about what my talk was about. I tried not to take up too much time, and I'm open to questions. If anyone has any questions about this, let's continue the remaining 6 minutes in a discussion format.
Yeah, my question is, how do you patch these servers in the airtight environment?
What do you mean by pass the servers?
Patching.
Patch. The Kubernetes clusters itself, right? Exact same way. If it's a pseudo air gap, in that case, it would be a little straightforward, right? You download whatever information you require on the proxy server. From the proxy, it would go to the air gap instance. But if it's a true air gap, then you're going to have to rely on physical media. So let's say you want to install a security patch. In that case, first you're going to have to get it on a local environment, something that's actually connected to the internet. Download the security patch, make sure that it's handling whatever case you want properly, and you don't have an additional backdoor or malware that's contained within that security thing. Once you've confirmed that, then you can take the physical media, take it over to the air-gapped environment and have it installed. One point that this reminds me actually is physical security. Since an air-gapped environment is going to exist on literally disconnected from the network, it's going to exist somewhere, right? Air gapping is usually done on self-managed clusters. So your servers are going to exist somewhere in a physical location. So you also need to make sure that the physical location itself is secured. If any of you have taken a look at one of those Life of Google videos, they actually show off how they have secured the Google servers. It's got like about 6 to 7 layers of physical security. You need your access cards. Even after access cards, you actually have to be a certified person. Only then you're allowed access into those data centers. So similar level of security is used for banks or these fintech organizations which we just talked about.
One more question. So suppose a bug goes into your software in a closed environment, and then what will be your next steps to get that fixed, or maybe how long will it take to get a security patch up to date?
When you talk about a bug, are you talking about a bug with the actual application?
Yes.
Okay. So in that case, a management tool. I'm being a little biased here, but there's Devtron, right? So Devtron has this feature where you can roll back to a previous deployment. Now let's imagine this. You've got your air-gapped environment. Inside your air-gap, you've got Minio. Minio is a caching solution. Or let's take a different caching solution, Redis, for example, any caching solution. In that caching solution, you would have at least two versions to roll back onto, right? So you've got the previous version, which you know for certain it works flawlessly. You can simply just roll back to that version, and the actual bug, whatever it is, developers will work on fixing that, test it thoroughly within their environments itself. And once it's validated that it's good to go, take it, deploy it in the air-gapped environment.
The same thing applies with the security patches as well?
Yes. But with for security patches, I answered this earlier, right? Like security patches are critical, especially if it's a really severe CVE. In that case, you need to try and fix it as soon as possible. But yes, if it's a truly air-gapped environment, you would still need to physically put it over there. Oh, one interesting tidbit. You can have an air-gapped environment on the cloud. Confused? Even I was confused in the beginning, but it's basically a game of the entire networks. You put your entire cluster through a VPC, and then you restrict access to the VPC. I wouldn't consider this as a truly air gap instance. It's rather a pseudo air gap, because at the end of the day, even the VPC is getting the connection through some sort of a proxy, right?
Do you have any more questions? Okay. So I hope you all understood this session, and thank you, Siddhant, for your insightful and engaging session, and we warmly invite you to join us on the stage for as a token of appreciation. Please.